Hello everyone. I'm making this video because I'm not feeling very well. My throat hurts really badly and I'm not sure if I will be at school tomorrow, but I thought we could try something different. If I'm not at school tomorrow, then you can watch this video and your assignment is going to be a review for your quiz. So this lesson is not a lesson that's going to be on your quiz. Remember, your quiz is over 1-1, both sections, so vocabulary and drawing diagrams and naming things appropriately with appropriate notation. And then 1-2 is segment addition. So those two things will be on your quiz, those two lessons, but the lesson 1-3 from Friday and also from today will not be on your quiz tomorrow. And if I am at school, then I figure we could try this. You could watch the video on your laptop, and then I will be there potentially to answer questions or to help you out. If during this video you feel like you need to stop and go back, then you have that freedom. You also have the freedom to watch it again if you need to. So this is kind of a do it at your own pace sort of thing. So let's go ahead and get started with this lesson. Remember that after we talked about points, lines, and planes, we really focused in on segments. And on Friday, we talked about how to find the length of segments, whether that was with the distance formula or with the Pythagorean theorem or on a number line. And today we're going to kind of take that a step further and say, what if we have a point that's not only between two other points, but also is exactly halfway, and that is called a midpoint. So the midpoint of a segment, and if you would like to highlight with me, I've got all my highlighters and different colored pens. The midpoint of a segment is the midpoint M of segment AB of a point that bisects. So this is a new word for us. Bisect means to cut into two equal pieces. That prefix bi, like bicycle, has two wheels. So a midpoint is a point that bisects the segment, or in other words, it divides the segment into two, like we said, bi means two, congruent segments. This is the halfway point. So in this diagram here, if x is the midpoint, then segment AX is congruent to segment XB, which means we do have two congruent segments, segment AX and congruent segment XB, which means that we can put tick marks on that segment as well. And if we were to look at a number line, finding the midpoint is actually finding the average between the 2 points. So averaging between 2 points or two things, remember, is adding those two things and then dividing it by 2. So if you look at the first example here, what is the midpoint of segment AB on the number line below? So here's segment AB. In this case, we're finding the average between the 2 points. So point A is at the coordinate -3. Point B is at the coordinate 1. So to find the midpoint, I will find the average between -3 and 1. So I add -3 plus 1, and because there are 2 points, two things, we divide by 2. So -3 plus 1 is -2. Divided by 2 gives us a value of -1. And if I go back over to my number line here, we can see that -1 is in the middle of points A and B. It's 2 units away from A, which is -3, and it's 2 units away from B, which is at 1. So on Friday we talked about the length, the distance between AB, which in this case the length between A and B would be 4 units. But if I want to find the middle is at -1, which is half of the 4 units. So it's 2 units away from each endpoint. Okay, so that's the midpoint on a number line. But what if the segment is on a graph? What if it's on the coordinate plane? So we're not looking at the number line anymore. We're looking at the coordinate plane. We're looking at x and y values. You will still find the average It's just that you have to find the average of two things. You have to find the average of the x values and the average of the y values of the coordinates. And so you can see we have something here called the midpoint formula, and that is averaging the x and the y values of your coordinates that are on the coordinate plane. Okay, so if we take a look at an example here, if this were on a graph, you would plot the points E and F. E is at -2, 3, and F is at 5, 0. So like we talked about with the distance formula, the x and the y values are coming from your coordinates themselves. So point E, this will be our x1 and y1 values, and point F, this will be our x2 and y2 values. Now, for those of you that are not highlighting, which is totally fine, I still want you to write down these examples as we do them. So, to set up this average, remember we are averaging, this is a point, first of all, it's an average between two coordinates. So I'm going to be adding the x values and dividing by 2, and I'm going to be adding the y values and dividing by 2. So we're averaging both the x and the y values. So the two x values of our coordinates here, in point E, our x value, or x1, is -2, and the other x value comes from point F, our x2 value is 5. So we're averaging the x's, the -2 and 5. We will also average the y values of our coordinates here. The first y value we have in point E is 3, and the second y value we have from point F is 0. So now if I average those points, -2 plus 5 is 3 divided by 2, and 3 plus 0 is also 3 divided by 2. This is a completely appropriate answer for our midpoint because they are simplified fractions. However, if you would like, you can also represent this as 1.5, comma 1.5, or even 1.5, 1.5, if you would like. So if I kind of consider what I've actually done here, if this were on a graph, okay, an xy coordinate plane, point E is at -2, 3, which is in here somewhere, right? And point F is at 5, 0, which is on the x coordinate over here somewhere. So what I'm really saying is I'm still finding the middle between these 2 points. It's just that the middle is on a graph. It's on the coordinate plane. And so if I look at this midpoint, if I go over 1.5, up 1.5, then there I have found the midpoint between those 2 points on the graph. So I just kind of want to visually show you exactly what it is that we're achieving here. So if we look at the second example, again, I have 2 points, P and Q. In point P, that's our first set of x and y values. So here we have, again, our x1, y1. And Q gives us our second values, x2 and y2. And again, we're really just still finding the average, but because it's on a coordinate plane, we have x values that we need to find the average of, and y values that we need to find the average of. So notice there aren't too many formulas that have commas in them. The reason why there's a comma in this formula is because it's a coordinate point. Okay, so it has an x and a y value. We are simply separating the x and the y values. This comma does not represent addition or multiplication. It is just separating. So again, our x values, x1 is from point P, which is -8. x2 is from the Q coordinate, which is -2. And then we do the same thing for our y values. We have a y value of 3 from coordinate P, and we have a y value of 7 from the coordinate Q. So I go on to simplify that. Negative 8 plus negative 2 is negative 10 divided by 2. And 3 plus 7 is a positive 10 divided by 2. So it looks like the point, the coordinate that's right in the middle between P and Q on the graph would simplify to this point that has a negative 5 for the x value and a positive 5 for the y value. So that's our midpoint on the coordinate plane between points P and Q. So just like the distance formula, we talked about the distance on a number line, we talked about the distance on a coordinate plane. We also talked about the length not on a coordinate plane. But let's look at one more example on a coordinate plane that's a little bit different. It says here, M is the midpoint of segment XY. So I'm going to go ahead and draw myself a picture. I don't have a graph, but I do know that I have this segment XY, and M is in the middle. M is the midpoint, which means that segment XM and segment MY have to be the same because M is exactly halfway. I'm also told that X has a coordinate of 2, 7, and I'm actually told where the midpoint is. M, the midpoint, is at 2, 7. I want to know what's the coordinate of Y? What's the other end point? If I know that M is halfway, and I started at point X, then where is point Y so that M is exactly in the middle? Oh, I'm so sorry. I made a mistake here. M has a coordinate of 6, 1. I just did the same point twice. I'm not perfect, folks. So let's try that again. M has a coordinate of 6, 1. Okay, 6, 1. Using my handy whiteout. You guys have erasers, but I'm using pens here. So the beginning of the segment is at point X, which is 2, 7. The middle of the segment is at this point 6, 1. What would the coordinate be for the other endpoint? There's an algebraic way to do this, but also I feel like there's kind of a common sense way to do this. And here's what I mean. If the x value for the first endpoint is 2, and the x value for the midpoint is 6, that means I had to go 4 units in the positive direction on the x-axis. Which means in order to go to point Y, if M is exactly in the middle and I had to go 4 units to get to the middle, well, I would have to go another positive 4 units on the x-axis to get to that endpoint, which means 6 plus another 4 is 10 to get to our endpoint. And I'll show you why that works here in just a minute. Similarly, I can look at the y values. If I go from 7 as a y value in the coordinate x to 1, the y value in the midpoint, I actually had to go down 6 units on the graph, which means to get to the other endpoint, I would have to go down 6 more units. So 1 minus another 6 units would get me to a negative 5. So what I'm thinking is the other endpoint would have to be at 10, negative 5. But here's how we test it. If I'm saying that I know that this segment has an endpoint at 2, 7, and I'm thinking that the other endpoint has to be at 10, negative 5 in order for the midpoint to be at 6, 1, we can check it, and we can actually do the midpoint taking 2 plus 10. Let's average out those x values and take y values 7 and negative 5, and let's average those. What I end up with is 12 divided by 2 and 2 divided by 2, kind of running into the hole punch here. Or in other words, I get this value of 6, 1. And guess what? That's exactly where our midpoint is. So what we did is we said, I know that M is halfway between these two endpoints. So we say, okay, well, how far did I have to go from the beginning to get to the middle? okay, let's go that same value from the middle to get to the other endpoint, so that the midpoint 6, 1 is exactly halfway. So our coordinate for y is looking like that value is going to be at a 10, -5. Okay, so it's kind of using some common sense to figure out if we know the start and we know the middle, let's figure out where the end is. And of course, we might see some situations that kind of look like segment addition, except we have a midpoint in play here, so we're going to have some equal parts. So if I look at number 5, it says find the length of segment PQ if Q is the midpoint of segment PR. So if Q is exactly halfway, notice we're not on a number line, we're not on a coordinate plane, we are just on a two-dimensional piece of paper where we have a segment drawn and we know that Q is in the middle of it. I know that the expression for the length of PQ is 9y minus 2, and the expression for the length of QR is 14 plus 5y. Again, if Q is right in the middle, then I know that the length of PQ is the same as the length of QR. So really, I don't have to do segment addition here because I know that these are equal parts. And if they're equal parts, then set the expressions equal to one another. So we could write this equation 9y plus 2 equals 14 plus 5y. And then we can solve algebraically to find the value of y and then plug it back in to get the length of PQ. So I'm going to subtract 5y from both sides. So that's 4y minus 2 equals 14. And then I'll add the 2 to both sides. So I end up with 4y equals 16, and then if I divide by 4 at the end here, then it looks like our y value is 4. So if I want to find the length of PQ, PQ has the expression 9y minus 2, so I'll do 9 times the y value, which we said is 4, and then subtract 2. So 9 times 4 is 36, I believe, I hope, let me check myself. Yes, that's 36, and then subtract 2. So that means that the length of PQ, or 9y minus 2, is 34 units. And it should be true that if I plug 4 into the other half, that I would also get 34 units if Q was right in the middle. And it turns out that's true, because 5 times 4 is 20. 20, add 14 on, I would also get 34 units for the other half. And then I could even say that the whole length, PR, would have to be 68 units if I added the 34 and the 34 together. Okay, let's look at a couple of situations where we have to draw our own pictures. So it says M is the midpoint of segment AB, so I'm going to draw myself a segment. Again, you should be doing this as well. It says M is the midpoint of segment AB, so I know that these two segments must be congruent, AM and MB, if M is right in the middle. And then I'm going to label with the information that I'm told. It says that the length from A to M is 3x, and the length of A to B, that's the entire segment, is 5x plus 10. Now, I know that it might be tempting to, because of the work that we did last week with segment addition, to set 3x equal to 5x plus 10. But resist that temptation, because if you wrote that equation, if you said that 3x was equal to 5x plus 10, what you would really be saying to me is that half of the segment is equal to the whole. And that is certainly not true. That's like saying half a cookie is equal to a whole cookie. No thank you. I would rather have the whole cookie, not the half a cookie. Okay, there's a big difference. So we cannot write this equation because it is simply not true. So how do we figure out what the other half is then? Well, if M is in the middle, then the length of AM should be the same as the length from M to B. So let's go ahead and copy the 3x into the other half. So what I'm saying is we could actually add 2 halves, 3x plus 3x, then set it equal to the whole, which is 5x plus 10. 1 half is not equal to the whole, but you put 2 halves together and that is equal to the whole. So now I can go ahead and do my algebra to solve from here. So 3x plus 3x is 6x equals 5x plus 10. Subtract the 5x from both sides, and we end up with x equals 10. So x is 10, and I'm supposed to find the value of AB. And I go back over to my diagram and my information here. AB is actually the entire length, 5x plus 10. So to find AB, I'm going to do 5 times x, which is 10, plus another 10. So I'm looking at 50 plus 10, which would be 60 units total. Also keep in mind to go back and check to see if this makes sense. If I plug x into each half, 3x, 3 times 10 would be 30. 3x, 3 times 10 would be 30. And 30 plus 30, the 2 halves put together, equal the whole, which is 60 units. Okay, so let's try one more. It says D is the midpoint of EF. So I'm going to draw that picture. D is the midpoint of segment EF. It says segment ED is 4x plus 6. You know what else? I did not put tick marks on my diagram. I'm going to do that right now. If D is in the middle, then that means segment ED is the same as segment DF. Okay, now what other information do I know? It says ED is 4x plus 6. DF is 7x minus 9. DF is 7x minus 9. Now take a look at the difference between these two situations. In number 6, I knew 1/2 and the whole. In number 7, I actually just know 2 halves. And if I go back up to example number 5, I also just knew 2 halves. So if we go back and see what we did on number 5, we said, well, if we have a midpoint and we have 2 equal parts, well then set those 2 parts equal to one another. We don't have to add them together. We don't have an expression for the whole segment. The same thing is true here on number 7. We don't have an expression for the whole segment EF. Now some of you might be saying, well, we could just add these 2 expressions together, which is true, but not helpful if we don't know an expression for the whole segment. So let's do like we did in number 5 and say if we know that we have 2 halves and those 2 halves are exactly equal to each other, then let's set them equal to each other. So 4x plus 6 equals 7x minus 9. So algebraically subtract 4x from both sides. So 6 equals 3x minus 9. Add 9 to both sides, and we get 15 equals 3x. And then finally divide by 3 to get 5 equals x. So when I'm looking at which segments I'm supposed to find here, I'm finding ED, DF, and EF. Or in other words, I'm finding what each half is, and then also the length of the whole. So let's go to find the length of ED first. So ED is 4x plus 6. So 4 times the x value of 5 plus 6 gives us 20 plus 6. So the length of ED is 26 units. And remember, we're just writing units to get in the habit of writing units, because sometimes when we do know inches or centimeters or whatever, then we'll be used to writing that at the end of our answer. Okay, next let's find DF. So DF is 7x minus 9. So 7 times the x value of 5 minus 9. 7 times 5 is 35 minus 9. And again, we would end up with a result of 26 units. Now, to find the length of EF, I don't have an expression to plug x into. But that's okay, because what we've just done is we've said that the length of ED, let me grab what color do I want to do here. The length of ED is 26 units. The length of DF is also 26 units. So it makes sense that if I want to find the length all the way from E to F, I just need to add 26 and 26 together. I need to add the two halves together to get the whole, which would result in 52 units. So again, we found ourselves with a couple of different situations here. We worked with the number line on the front here and finding the average. We worked with coordinates on a graph, finding the midpoint. First of all, when we knew both endpoints and we had to find the middle, but then a different situation where we actually knew the start of the segment and the middle and we had to figure out where it ended. And then finally we got into diagrams that were more like our segment addition, and even in that we had two different situations. Like in numbers 5 and 7, we actually had an expression for both halves, so we were able to set the two equal parts equal to each other. And then number 6 was a little bit different because we knew what 1/2 was as well as the whole expression. So we were able to take that 1/2 and essentially double it because we knew that the halves were equal, and then set it equal to the whole expression. So remember, if you have questions over this, please feel free to ask. You can go back and rewatch any part of this video that you need to. And your homework tonight is going to be a quiz review, which will not include any of the 1-3 material. So we'll address that again on block day. I hope you have a good day, and please be kind to the sub and to each other, of course.